So here we will see what is called a planar graph. Okay. So the first example is, so that is called water gas electricity or gas water electricity problem. So suppose ABC, 3%. They live in a woods, in a house in woods. Okay. So we must cut a path such that
Yeah.
uh, let me write down.
Ah, planner. That means we can draw it in the 2D, is right?
Right, right. We can draw them in 2D plane.
Yeah.
So suppose A, B, C. So these are three persons, and you have three utilities. That is, one is gas, one is water, and one is electricity. So yes, so let us draw the edges. Okay. So the thing is, every person. So these are three persons, right? And so this is the G, gas, water, and electricity. So these are the three utilities that every person need, right? So
I
now
see.
the thing is, so they are not good friends. So they are enemy. They are not good friends. ABC. So they want that the connection, the gas connection, water connection, and electricity connection should not intersect each other. Their path, right? So they don't want to their path to cross each other, right? So can this be done? So that is the idea.
The
So
blue is water, but water. Ah, okay, okay. Water is okay.
yes.
The
So
on is okay. Yeah.
they do not want,
Grass is on a.
right, any path to cross each other.
So impossible is right.
Yes, tell.
Oh, just look it and it's same impossible if.
Yes, yes, it is not possible, right?
Mm,
So the thing is, yes, we'll see why it is not possible. But the thing is, if you look at the graph, so it is
mm,
actually a complete
mm,
bipartite graph, right? So it
mm,
is K3 comma 3. So this graph we can draw it equivalent to K3 comma 3. So what is the partition? I can keep
yeah, yeah. Okay,
this
three, three.
three.
Mm,
Yes, I can give this three in one partition, and I can keep ABC in one partition, right?
yeah, 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 yeah.
So it is K3 3, right? So that is the next proposition. So means we
Yeah.
cannot draw K3 3 without crossing.
Oh. So the problem here is how to determine quickly the graph is planar or not. Yeah.
Yes, yes. So that is the thing.
Mm. Something sometimes would be NB hard
Yes, yes,
problem.
yes. The problem will be MB hard. So that is sometimes the problem.
Mm.
Okay. So the next proposition gives us an idea. So that K5 and K3 comma 3 cannot be drawn without crossing.
Mm. Mm.
So without crossing of edges, we cannot draw this K5 or K3. Okay.
But in this statement, we just conclude about K5
Yes, yes.
and
Only this two graph. Yes,
K3.
we'll see in general how to
We
conclude.
cannot conclude about K4 is cross or not, is right?
Yes, yes. K4 we cannot tell anything till now.
Okay, okay, okay. Just that. Yeah.
Right.
Hmm.
So let us see.
Hmm.
So we consider a drawing of K5 and or K33 in a plane. And let C be a spanning cycle. We can choose any spanning cycle, right?
Mm.
So suppose we'll prove a contradiction. So the thing is, suppose the drawing does not have crossing edges, right? If the drawing does not have crossing edges, then then C is a closed curve, right?
Mm.
So it is drawn in a closed curve. So now the chords of C must be drawn either inside or outside this curve because they are not crossing, right?
Mm.
The chords of C inside or outside the curve, right?
Mm.
Fine.
Mm. Right. Mhm.
So and two
Mm.
chords
Mm.
uh, conflict if their endpoints actually occur in an alternating order, right?
Mm. Wait. We have C is
Spanning cycle.
spinning cycle. Spinning. Sometimes I
Yes.
confuse about
Yes.
spinning
Spanning is it.
machine.
It cover all the vertices. So it is a cycle that takes consideration all the vertices.
The possible cycle that's cover on vertices.
Right. Right.
Uh, it's related to K5 or not?
Yes. Yes. For K5 and K3 we are doing. So we are taking a spanning cycle.
Mm, mm. If Troy does not have a crossing edge, then she it draw as a Wasker. Uh, I cannot read this close.
Yes. Yes. So the thing is, this part is a closed curve.
Close.
Right.
Close. What does it mean, close?
Yes. So the thing is, okay. So for example, this K5 if I take,
Okay, fine.
so then so there are five vertices.
Complete fine. Yeah.
Yes,
Yeah.
complete graph of five vertices. So I can take a
Mm.
spanning cycle so that cover like this, right?
Uh, and spending does mean it should be in the graph. The subgraph is right.
Yes, yes, it is a subgraph and it
Uh,
covers all the vertices. So this
uh,
is a
uh,
closed curve, right?
uh. But
Now,
just some graph we don't have spending cycle is right.
mm, yes, yes, we
For
can have.
example, this graph we delete one s, so we cannot find the cycle with the size five.
Yes, yes.
Yeah, okay. Just yeah, okay.
So this is a spanning cycle and this is a closed curve, right? So what is closed curve is?
Close.
Yes,
Close.
so this is a closed curve. And suppose if I want to draw any chord, right?
Uh,
So either I have to draw inside the curve or I have to draw outside. So, right?
yeah.
So that is what I'm saying. So every chord of C of this cycle must be drawn inside or outside the curve.
Mm,
Because we are saying that the edges do not cross each other, right?
yeah.
But But when a chord will be conflicting or they will cross each other, so the condition is that is what you are doing next. So two chords conflict. So conflict means they cross each other if they are endpoints on C occur in alternating order, right? So what are the endpoints of the chord here? So the thing is endpoint of this. So what are the chords I have to draw? I have to draw this chord, and this chord. These all chords I have to draw because I have to K5, right? I have a K5.
If they are inborn in C occur uh, uh, occur alternating ended.
Right. Alternating means the inside one should be not there. That's why alternating, right? So alternating means what? So this I have, then I don't use these two. I use this one and this one. So these are the chords, right?
Uh,
So that's why alternating. So now, so if I draw this edge, this is one chord, that is fine. If I
uh,
draw, this is one chord, right? That is.
uh,
But now I have to draw a chord between this and this also, right?
uh,
So that I can draw outside. That is fine.
uh,
Also, I can draw this one outside.
uh, uh,
Right? So it is either inside or outside, right?
uh,
But now what is left? One is left still. So the thing is, one left is from here. I have to join here. So this neither I can go from inside, neither I can
mm,
go from outside.
mm. So to call conflict,
Yes,
yeah, conflict that means that is cross, is right. If they are endpoint, they are endpoint on C occur alternating ended.
right. So here, so this I cannot join from inside, right? So if I can join from outside, I can join. So that I have joined. So now the left, only the left thing is from here, right? So from here I have to go to this thing is left, right?
Uh,
So
left,
this thing is done.
uh,
This chord I have joined like this one, right?
uh,
But what about this chord?
uh, uh. I know this conflict was in the statement. I don't get the condition. If
Yes,
there
yes.
boy and boy on C
Yes, yes.
occur.
So the C is the spanning cycle, right? So C is the this is the spanning cycle. Now the chord endpoints are what? So endpoint of the chord is either this and this is one endpoint, right?
Mm.
And also
Any two vertices. Yeah.
yes, but this and this, right? But the thing is they are alternating because the vertex that is between these two, that is we are not connecting with that, but because that is already used in the cycle, so that's why it is called alternating.
Alternating, that's mean not agency.
Yes,
I mean, just in English, I don't get the alternating.
yes. Alternating means one after the other. Means it is skipping one next and using
Okay, okay, okay. One, three,
right, right, right. That is what.
five. Yeah, yeah. Okay. Skip one
Yes,
between
yes,
them. Okay. I got it. Yeah, yeah, yeah. It's the one condition
yes,
to we may have other condition, but one
yes.
condition is it should be alternating. Yeah. Okay. Okay.
Right. And when two chords conflict, we can draw only one inside C. So inside the closed curve and one outside, right? Outside C. So that is how we draw it.
mm,
Now, so when C is a 5 cycle, so this is a 5 cycle, right? At most two chords we can go inside or outside, right?
mm,
So when C is a 5 cycle in K5, at most two chords we can draw inside or outside, right?
mm,
But there are five chords, right? Total
mm,
there are five chords in K5, right? Because the total number of edges in K5 is 5 choose 2, that is 10, right?
mm,
And on the cycle we have used 5 edges, right? So remaining number of edges is 5, right? So they are all chords.
mm,
So but I can draw two chords that is outside the curve and two chords that is inside the curve, so
mm,
we are still left with one. So that's why we cannot draw
mm,
properly.
mm, mm. Yeah, yeah, yeah. So,
So since there are five chords, it is impossible for embedding. So it is not possible to embed in the plane, right?
mm,
So we saw that K5 it is not possible. Now let us see for K33. So K33 is a 6 vertex. Total number of vertices is 6. So let us draw the curve.
mm,
So so this is my spanning cycle.
mm,
So total number of edges in K33 is 3 times 3 9. Total there are 9 things, right?
mm,
So a 6 cycle in 3 comma 3 has 3 pairwise conflicting chord. So the thing is I can draw a chord from here. This I can draw, right?
mm,
So this is the alternate thing, right? And this I can draw from here,
mm,
right? Because 1 minute. Let me do the partition first.
mm,
That will be clear. So the partition is, this is one partition. So this is the partition, right?
mm, mm,
And the other partition is this one, right? Okay. So the one chord what I draw is this one. So this is first one chord, right?
mm,
Now I have to join
mm,
this chord I have to join, right?
mm,
But this chord I cannot join from inside, so I have to go from outside.
mm, mm.
So I join from outside, right?
Mm.
So this is fine, right?
Yeah, yeah, yeah. Mm.
And one more left is I have to join this one.
Mm, mm,
But this one neither I can go inside, neither I can go from outside.
mm,
So
mm,
that's why it is conflicting. So this is the three pairs of conflicting chords, right?
mm, mm,
So we can put
mm,
at most one inside
mm. Yeah.
and one outside, right? So it is not possible to. So embed in the plane.
Mm, correct. Mm, mm,
So at least for these two structures, your K33 and K5, we know that they are not planar, that you cannot embed in a plane, right?
Mm. Yeah, yeah. I see. Okay. Mm.
Okay, right?
Mm.
Okay. So yes. So the next definition is
It's okay. We can close here. Yeah.
okay.
But yeah, I am